Yeah, it's that time again. Time to dig out the fluted filter paper Christmas angel. Time for Santa to bring us some goodies on the tree. And under it amidst the polyester snow. Just what we wanted. Ethanol is always good. Iodine rocks. That's a sexy new condenser. Our very own bottle of borohydride. Woohoo! It's currently looking like a red Christmas. Santa has been so good to us this year that we can really only do one thing to repay him. Turn it from a red one into a white one. Let's see if we can do this on a small scale. Okay, you know that red phosphorus is pretty stable. Let's set fire to a small bit. Pretty inflammable. It's a phosphorus pentoxide white smoke Christmas, but that's not quite what we had in mind. Red phosphorus is a polymeric form of phosphorus consisting of long chains of P atoms. It comes in slightly different colors depending on the length of the chains. When heated, the chains break and reform P4 molecules which are much more reactive, especially with oxygen in the air. This P4 molecular form is known as white phosphorus. We're left with a bit of gunk after the red phosphorus burns. It's an old sample, so it's probably been oxidized a bit and there's phosphoric acid in there. But let's try and see what happens. A caution! White phosphorus is really nasty, evil, bad stuff. It melts at body heat temperature and spontaneously burns in air. If you touch it, it will stick to you like napalm and mess you up. It is more toxic in solid or vapor form than cyanide, and will take several agonizing days to kill you. Be super careful. We're more scared of this stuff than we are of sodium metal or alkali cyanide or azide salts. So let's do a first experiment and see what happens. We've got a small test tube here in a clamp stand, and we'll add some red phosphorus to it. Always nice to redecorate the work surface with a bit of red P. Merry Christmas, Tom. Okay, here we go. About an inch in the test tube. To stop the air getting in, we'll add a scrunched up sheet of absorbent paper. We'll allow some space for the phosphorus to condense. Okay, it's showtime. Let's get some mood lighting and ventilation on. We allow the tube to cool and then we'll get it into ice water in order to chill it down. There's lots of yellow solid in there which took a while to solidify, so it's got a low melting point. We figured we'd play it safe and first of all get some water into the test tube so we avoid the risk of fire. White fumes appear as the paper is exposed to air. But we douse with water and add some more to the test tube. Here we go. Quite a bit of dark solid still remaining, but definitely something else has formed in there with a yellow-orange color. Even when wet, the end of the paper that was in the tube starts to smoke ominously. If we place this in the rubbish, we'll risk burning the house down. So we'll need a way to clean up any paper or reaction mixtures containing white phosphorus. We hear that sodium hypochlorite bleach solution can neutralize and oxidize the phosphorus, so we'll try this out. We'll leave this in here for a day or two and then flush down the drain. So back to our tube. It's cooled right down now and we'll break up the solid using a metal rod, and then see if we can sort out some pieces of orange product. We probably broke that up a bit too much, but there are some small pieces of orange solid in there which we can get out. A word of caution. Add water again to the tube once done and leave there until you completely wash it up. We lost a test tube in a practice run when one of these tiny bits of phosphorus caught fire and broke the glass. Despite this though, we couldn't get any of the tiny phosphorus pieces to auto-ignite when we removed them and put them on filter paper. The tiny bits melted together under the heat of oxidation to form a blob, which smoked away. But no fire. Okay, so let's do this again, only with a slightly different collection process. We've added a little bit more red phosphorus into the tube, and this time we've packed it down a bit. We're going to insert a rolled up filter paper. The idea is that the white pea will collect and solidify on the inside of this. We've scrunched up and tapered the ends so the tube is protected from the atmosphere. Let's rock and roll. Once we see liquid drops, we turn the tube on its side. Again, we wait to cool, and then place into cold water. But the phosphorus has hardened and basically glued our filter paper to the side of the tube. We use some boiling water on the tube, and this melts the white pea. So let's see if it's possible to actually remove the filter and get it in the ice water without blowing the place up. We pull it out about 1 inch and the paper starts to burn spontaneously. Molten phosphorus is angry reactive phosphorus. We douse with a bit of water and then do finally get the paper out. A narrow escape. We might not be getting much white pea, but we learn about its character. It's awkward, hard to handle, just wants you to mess up. takes no prisoners, and is pretty bad-tempered. Okay, let's try a third time and with a variation. Our toxic waste dump is building up. This time we're going back to absorbent paper, but we're using an external layer of greaseproof baking paper. This should stop the phosphorus from soaking into the paper. About an inch of red pea in the tube. We'll run the reaction with the tube at a tilt like this. Let's see if we can collect that liquid product. Looky what we got here. We let this cool and gently rotate the paper to prevent it sticking. We'll add water using the technique from the first experiment. Let's do it. No fireworks. And a nice big piece of yellow pea has come off the baking paper into the water. So we definitely recommend the wet method for dealing with this stuff. Out of the water it starts to smoke within seconds. This time we definitely get a hint of an unpleasant garlic-like aroma, which is apparently characteristics of white phosphorus. Again, in such a small quantity as a single lump, it's hard to get it to auto-ignite, but I wouldn't take your chances with it. It's going to do whatever you don't want it to. One last experiment we wanted to do. We made up a warm strong sodium hydroxide solution. In theory, white phosphorus should react and form phosphine gas, which in a high enough concentration is inflammable spontaneously in air. That was cool. Okay, screw it. The phosphorus melts and soon reacts. Pretty white lights dance around on the surface as the phosphorus is carried to the surface by the bubbles and burns in the air. Do this in a test tube and you can hear the occasional pop of the phosphine igniting and exploding. This is enough for us. Maybe a more daring chemist will scale this up, but we really can't recommend it. But in the end, it turned out to be a white pea Christmas and they all lived happily ever after. Stay tuned.